I'm going to actually hand it now to Rich Doyle, who's going to introduce our first keynote speaker. So, Rich, if you're able to do that, on to you.
Okay, thanks very much, Dan. It is my pleasure to introduce Dr. Usama Fayyad as our first keynote speaker for the workshop. So we have 3 keynotes planned, one each day from industry, NASA, and academia perspective. So Usama will offer his remarks from the industry perspective. Usama's had a truly impressive career arc. He's currently chairman at OpenSites, focusing on AI, big data strategy, and new business models for data. He is the inaugural executive director of the Institute for Experiential AI that is being launched at Northeastern University, and he's also professor of computer science there. He was the global chief data officer at Barclays Bank in London, and he's launched several key startups and has been chairman, CEO, and CTO of several startups in both the Seattle and the Silicon Valley area. He was chief data officer at Yahoo when one of his companies was acquired by Yahoo back in 2004. He's held research leadership roles at Microsoft Research and was the founder of JPL's Machine Learning Systems Group, and I humbly acknowledge my role in helping launch Usama's impressive career. He has over 100 technical articles, over 30 patents. He's a fellow of both the AAAI and the ACM, and he holds the PhD from the University of Michigan. Usama, I'm delighted to hand the ball to you if you can grab the screen for your keynote talk.
Thank you, Richard. First, let me check, can you hear me?
Yes, we hear you.
Rich, it's an honor to be back, even virtually in Pasadena. I was hoping to be there to meet so many of the old friends, and I will actually start by saying when I started my career, Rich was my first boss ever. Actually, he was my boss even when I was an intern. And he was an incredible boss, extremely supportive, and was instrumental in helping launch a lot of the key projects that kind of got me involved in data science as well as in kind of data for scientific analysis. I'm going to, and I'm very grateful for that, obviously. What I'm going to do here, so it says to me sharing whiteboard. Am I sharing the right thing? Ah, okay, I see it. I need to change to this. Let's try this one. And
yep.
And hopefully you're seeing it in show mode, right?
Yes.
Excellent, excellent. So in a way, this is designed to be for something completely different in terms of, and then you may be wondering, why am I talking about this? Why am I talking about the industry view? Well, when I was at JPL and before, I would say that scientific data analysis was in the lead. It kind of, you know, academia and places like JPL, Caltech, etc., were way ahead of industry who would look to us for leadership and guidance. And we were the only ones slugging around at the time, terabytes and multi-gigabytes of data. That picture changed dramatically post kind of the internet commercial boom as well as the birth of the big giants. So it is kind of unfortunate, and I think the time is about right now to kind of flip that, because it saddens me really to see that you know, things like ad targeting and things like you know basic commercial applications utilizing technology that's way ahead of reach for the scientific community. So to me, I want to deliver that message in the context of AI and how important AI is and how important data is to AI. And within that, come back at the end and kind of say, why should this be meaningful to the scientific community, and how we should think about it and what we need to think about. I know Larry mentioned, for example, that Dan is leading up a project to think about a data strategy and a data architecture for JPL. You know, we've been doing that with a lot of companies, big enterprises in telco, in banks, etc. And it's an extremely important thing, and it's a huge enabler of actually doing through AI. So part of this is, and because of the audience here is familiar with AI, etc., I'm going to skip through a lot of the material very quickly because I assume you know it. I'm just going to give you a flavor for my own brief history of AI that kind of evolved out of me being requested by many boards, many executive committees, many companies to come in and tell them, what is AI? Why is it relevant to them? Why should they be thinking about it? And in some cases, it's like, how do they tick the box that, hey, we're doing AI? And a lot of this kind of alerted, opened my eyes and gave me a new view to the whole field that I'll kind of share with you very fast, but then move on to data and big data and all of that. So you all know AI is an old field. It didn't start, yesterday. It's been around for a long time. Some of us, are aware of its beginnings. And it has gone very far. It has achieved certain challenges that we thought define intelligence, only to realize that in the definition, the use of computers to simulate human intelligence, we still don't understand human intelligence. And this is the source of many, many, many problems. To date, we don't have algorithms that kind of explain how we manage to do it, how we manage to do some of the things like common sense reasoning, natural language understanding, etc. Now, there was a first generation, I would say, that kind of met with an AI winter, and the AI winter, of course, was driven by the overhype around kind of we can solve the problems, etc. But we did learn a lot of stuff, and the technology did work in certain areas that matter. The practical applications also worked, expert systems, etc., and especially game players. We'll come back to game players in a second. And it only worked in areas where we had extremely narrow problems. And this is an important theme, and I'll talk about why in a second. The second generation, which was 80s to 90s, actually, as I was finishing my PhD and joining JPL, it was kind of the beginning of the second AI winter. And what we realized there is why the second wave failed, because we had common sense reasoning, natural language understanding. We couldn't get that solved. We couldn't get natural language understanding to go. We had severe estimation of challenge problems. I'll use machine vision as an example. And probabilistic reasoning now, instead of logic, didn't quite scale to help us do the reasoning at the time. The problem was worse. It seemed like you needed to know everything about a problem before you could do something intelligent. Now, and of course, we learned that weak algorithms lead to very brittle solutions. There's no magic in neural networks, etc. But I'm going to come back to this kind of problem was worse. Lesson one, and these are lessons I learned over the years, is reduce the problem domain to where complete knowledge is possible. And the only tool I have for that is make it as narrow, as focused as possible. Now, games are an extreme example of this, right? If I give you a chessboard or a checkers board, I give you all information in the world. You don't need anything else. Luckily, many engineering and scientific analysis tasks can be reduced to this and can be solved that way, and we can make the machine seem intelligent because in that micro universe, they have complete knowledge. What about problems like machine vision, big challenge problems, right? Here's one of my commentaries here, which is almost like a joke in the machine vision field. Let's say you want to recognize the items in a basket, right? Amazon Go now kind of tries to do this as you're picking up the items in their stores, the specialized stores. It's a hard problem. If the objects are a different orientation, different lighting, different partially occluded, etc., I can't solve it. Yet we come up with a solution that really works, right? And the solution that really works is we slap a barcode on everything. And for a long time, the joke in machine vision was, well, we can solve the machine vision problem, just slap a barcode on every object in the world that you have to deal with. The thing is, though, it's an elegant solution, works in the dark, works at different angles, works much faster than human vision. However, has nothing to do with how we see and how we understand scenes. And that's a typical theme, right? These solutions get solved in an engineering solution that has little to do with how intelligence is done. The initial hype of the 80s, by the way, created a whole bunch of predictions that never came true. At the time, jobs were going to be replaced. Instead, we created many more jobs, and they were higher value jobs. The US at the time was afraid of the Japan AI program, the 5th generation systems, which turned out to be much. Of course, today we see very similar things, unfortunately. The level of hype is still there, whether it's around self-driving cars, or it's around many of the other areas with robots, everything, a lot of predictions we're going to be jobless, brainless. China 2030 AI is now the new Japanese fifth generation. I'm actually not as worried about it, even though at the time, and for good reason, many people are worried about it. But I actually think that the problems are much harder than the hype, which is why I predict winter is coming. We are going, because of all this hype, we are going to experience a third AI winter. And it's within the next 5 years, maybe even sooner. However, there's a piece of good news. One part of machine learning, AI has survived both AI winters, right? And that's machine learning. And I'm going to spare you the details of the history. I love the example of Arthur Samuel and his checkers player. A, because it's old, and by the way, the machines with the tapes he's using that's a real picture. But B is because he was not a checkers champion, yet playing with his program, not only did it learn to play better than Samuel, using some very simple rules in learning, right, just data. It became a better checkers player with each game it played, and Samuel had the insight of saying, what if I fed it all the championship games, and guess what? It suddenly started beating champions, right? And by the way, I use this example because our state-of-the-art in machine learning has not advanced much over this kind of approach, right? I know I'm hopefully not offending you by saying this. There's good advances. We understand kind of how these models behave with data size and complexity of space and all of that. We have better understandings. We don't necessarily have better algorithms. The fundamental algorithm for learning, that incremental refinement, is still the same. Now, machine learning survived both winters, and my favorite quote here is by my friend Peter Norvig at Google: we don't have better algorithms, we just have more data. And this is key for us to think about, despite kind of all the stuff that's been happening. We, of course, see a second incarnation in a big way with deep learning, which has contributed to our ability to solve many problems in what I call procedural knowledge, problems that we don't know how to kind of state the solution to, like object recognition, speech recognition, high dimensional regression. But it comes at a huge price of very high complexity and a need to do a lot of human engineering and design of how do you lay out that network, how do you increase the number of inputs, and how do you deal with the outputs being in such a huge space, and how do you deal with all the parameters in these kind of deeper things. There's good algorithms there, don't get me wrong, but there's still regression. However, a problem I see for our field, and I want you guys to think about, this is my AI Redux slide. AI has all these different areas of work, right? From translation, classification, clustering, speech to text, image, and I didn't show everything here, right? Yet, if you really look at what's been happening, you kind of strike through most of these fields, and people take the machine learning shortcut, right? They basically say, we have more data, we don't know how to solve the problem, let me regress my way around it through regression writ at large, which means kind of classification, regression, effectively predictive modeling, right? And that's the only tool we have that's been working. And that's my own observation, right? So again, it emphasizes the role of data. Despite all of this, there's been many amazing applications, right? Interesting ones like Erica Mathematica, embarrassing ones like Microsoft Tay. I don't know if you guys know about Microsoft Tay. It was a chatbot that Microsoft put up and kind of challenged the community to use it. And within a couple of days, people figured out they can hack it by just talking to it in bad language. And they even got it to kind of repeat social slurs, racial slurs, etc. And Microsoft proceeded to kind of shut it down and pretend it never happened. I actually bring it up because it's a good learning experience of do not overestimate the capability and do not underestimate the difficulty of solving some of these problems. Many useful things, by the way, undeniable. I use Google Maps all the time, despite the issues I have with it in privacy and all of that, and you all should have. There's many promising things like facial recognition. Alexa is now way over this number. It's probably 500,000 skills, and that's a good approach to kind of doing this in again, narrow domains. there's annoying stuff. I was personally responsible for the behavioral targeting business becoming big. Unfortunately, it got taken to amazing extremes now, and good luck to you if you ever look up anything on the web trying to buy something. You'll be targeted with ads for the rest of your life, unfortunately, on that topic. Lots of promise and big bets. Autonomous driving, which I don't believe we're ready to solve for high-speed moving vehicles, but we will solve it for sure for low-speed moving vehicles like garbage trucks, for example, where you can stop, call for help, and recover from situations you haven't seen before, and that's very important as a lesson. We'll come back to that. Financial advisory, drug discovery, scientific knowledge compilation, lots of amazing stuff happening there. So we said it's all about data, really, because it's about ML and using ML as a shortcut. And that brings in the whole world of big data. When I was at Yahoo, one of the ways I challenged the founders was to say, look, we built a whole company on open source, yet we haven't contributed anything. And we chose, I was also responsible for Yahoo Research, and I pushed kind of to open source the Hadoop project and to kind of get it out there as a way to democratize search. We thought at the time we would be creating other competitors to Google. Of course, we never anticipated that it would become the preferred storage mechanism for many, many, many organizations, and a way to do storage at high performance a lot cheaper than what these organizations do. Now, this addresses big data, this addresses storage, but it also addresses variety, which is the big part of big data I care about. Here's a quick example, right? Let's say you have a record of customers, age, gender, address, job, kind of what things you've done. What's amazing today is, of course, I can overlay this in almost no time with a professional graph around this person. I can do searches and get all sorts of documents related to where they work, what they do. I can overlay it with a social graph from a variety of social networks now that give me feedback as to what they like, they don't like, etc. I can pull videos, I can pull images, I can pull meta tags and all sorts of forgotten information, and I can pull all sorts of writings relating to the job, to the person, to the place, all of those things. Now, when you have this mix of graphs, unstructured data, structured data, all of that, how do you deal with it, right? And this is where kind of you have to really think about, to me, big data is about the explosion in variety, not necessarily the explosion in size, even though it is happening as well, right? So lesson 2 for pragmatic AI that I learned through the years is data is a necessary enabler of practical and applied AI. So make sure the data is managed and captured and managed as an asset. In most companies, data is a liability. It's not really an asset. It's not being used, and it's waiting there either to be externally hacked or internally leaked. That dynamic needs to change. I am so happy to see someone like Dan thinking through kind of what is the data strategy of JPL. How do we take these assets and lower the bar for making them useful and truly assets that are used all the time? And in industry, you have to make sure you can deal with a variety of data. I'm sure it's true in science too. Even though we've been doing a lot of very narrow analytics around narrow sensors, trust me, the minute you overlay it with all the other information, you have the same problem, right? In industry, it's social media, it's documents, it's customer service recording. In our world, in science, it's kind of other instruments, other collections, other maybe relevant observations in different modalities, etc. So it boils down to big data. So what are we doing with all this data? You know, the world in industry has transformed from simple structured transactions to rich, complex, unstructured interactions, which are kind of bewildering a lot of companies. And we'll come back to talk about this in a second. So the question is, how do you capture and utilize this data? To give you an example, banking, right, where I worked, I spent 3 years at Barclays in London and working globally. You know, in the old days, banking was very intimate. It was very heavy on personal knowledge, right? The branch manager would know the customers personally almost, and the staff. They would know who's a good credit risk, who's not. They would know what's happening. Is this business going up or down, etc. A lot of these things, when they scaled and went digital and went to larger numbers, didn't scale, right? So now the question, something as simple as KYC, which is a regulation requirement, know your customer, right? Required by a bank to know kind of your job, your name, your source of wealth, all of that. it becomes in a place like Barclays, a few $100 million a year just to do KYC, just to do a refresh, not to know the customer intimacy. So data is a way to bring back that intimacy and understanding of what you can do with each person. Now, lesson number 3 that I learned over time, AI and machine learning, they expect data in certain formats and at certain levels of granularity that most typical data systems do not provide, right? Summaries made for humans, analytics made for humans, useless for machine learning because machine learning needs the detailed data. Getting to the detailed data and understanding all the issues with it is a big deal, right? And it's a big deal in science. It's a big deal in industry. It's a big deal everywhere almost, right? In search, in anything you like. So that ability and that thought needs to be in place. And most people think still of data as kind of how does a human consume it versus how would a machine need to consume it? And that's a challenge. So, by the way, I talked about moving from the transactional view to the intent view, understanding intent behind what a customer is doing. Here's an example. Kelly deposits a check into her account. She's in good standing. End of story at the bank. In reality, the bank could have known that Kelly is trying to save to buy a house from many hints it gets. Kelly has a student debt. Kelly has just gotten married. Well, guess what? When the content or what you have to offer to Kelly that's very relevant and that helps Kelly is something that would help her either refinance debt or go after kind of saving for buying that house or enabling it faster, right? That, by the way, the stuff on the right is available to any bank because of the way you transact with them. You just have to dig it out of all that data that's kind of stored transactionally in a way that doesn't make it easy to get out. And this is my view of the world is, a typical organization, let's say a bank, you ask, what is the customer's view of the bank? And the answer is it's very transactional, right? They have a mobile app, they have a branch, they may have a point of sale, they have a wallet, right, an ATM machine. You ask equally the bank, hey, what's your view of your customer? And it's equally transactional, right? This person, generated this much fees. This person, applied for a personal loan and was denied. This person, tried to do a mobile transfer or wants an auto loan. In reality, something else is happening that the bank has full view of, right? There are life moments. You're trying to buy a house, getting married, buying a car, getting a degree, retiring, having a child. Or you're trying to do day-to-day stuff, commute, pay utility bills, entertainment, shopping, travel. That is the intent, right? And if you understand the intent, then the kind of conversation you can have with your customer, an understanding of what they're trying to achieve becomes much more important. By the way, if we have time, I can map this to scientific data analysis, believe it or not. Lesson 4 then is AI operations, whatever you put in place, it needs to kind of strive to collect intent, right? What does a user want from this data set? What does a user, what does, for example, in this case, the customer, what are they trying to achieve? Because once I model actors and intent, I can actually start functioning at a higher level of intelligence. By the way, this is very hard. Almost no organization does this today, with a huge exception. Somebody like Google has mastered the art of figuring out intent simply because you type it to them. You go to their box and you tell them what you're looking for. And that's an amazing interface, right? And then they can kind of structure the results based on what you told them, right? But think of this now generalized to kind of inferring this information. Talked about big data and a platform. I just wanted to share a quick example with you. When I arrived at Barclays, one of the big collaborations I started was with cybersecurity team, who basically wanted to collect data from all over the bank, and they have kind of the remit and the permission to grab that data, and they wanted to bring in external events, etc., for the purpose of cybersecurity. The problem there was prioritizing alarms. We generate a lot of alarms with all the tools that are monitoring what's happening on the cyber. And then the SOC, the Security Operations Center folks, don't know which alarm to follow, how to investigate it quickly, how to give feedback, etc. So we built that system, and we needed to bring a big data stack, and I had to bring open source into the bank, which was a huge thing. Bringing new technology into a 325-year-old British bank was a challenge, but they actually embraced it once they understood the value and the fact that open source is not a threat, it's a capability. What's happening is, what happened is once we did it for cybersecurity, all these other departments suddenly found huge uses for the data. And our biggest problem was, well, do you have access, and what access, and what are you allowed to see and not, right? So fraud wanted it, financial crime, which actually the technology team reported to me, wanted it, marketing wanted it, risk wanted it. And risk, by the way, in a bank, that's like a multi-$100-million a year function, right? Just to assess kind of the risk of the bank and the risk of the customers. So data fusion is a big deal. I think it's a huge deal for JPL. It's a huge deal for most of you guys dealing with scientific data. Like, how do you really fuse it in a way where you can connect the different related things, even though they seem unrelated at collection time? One of the things to learn from this experience with cybersecurity was the fact that, in cyber events, some things are easy to classify. We know they're good. Known goods, known bads are easy to classify. The middle is very, very hard to classify. And this is where kind of the merger of the human-centric and what we're calling Exponential AI at Northeastern, which is AI with human in the loop. How do I leverage the human to figure out the stuff that's hard to figure out, but how do I leverage them correctly, where they are more in control, more able to see, let the technology do the heavy lifting of the mundane work, and then let the human jump in at the right point to give you. So when we say this alarm is important, that's an opportunity, right? The SOC operator would look at it and say, no, not really, this is a false alarm. Now we get smarter at realizing what's a false alarm. Or if they decide it's a true alarm, well, the data system, the data fusion can help bring all the context around and visualize it very quickly so that they can decide, do I investigate further? And if I investigate, a typical investigation in cyber, and by the way, in scientific inquiry too, is bring me all the data around this. Hey, grab the emails, grab the contract, grab the documents. That, in a bank, that might take weeks to months. If you have data fusion, that can be done in hours, right? So that's a huge game changer in terms of rapidly kind of gaining intelligence over time. That brings me to lesson number 5, which is kind of my last lesson. I have several more, but I'm not going to share them here. There is no autonomous AI. There is no general AI. It is about hybrid AI, or now I should be calling it experiential AI, or AI with human in the loop, where the low-level work is done. And algorithms, and this is very important, they need to have an ability to know when they do not know, so they know when to call for help. Applies to spacecraft, probably a lot less because they're so far away, but applies to almost anything you put out there in real world and in the analysis cycle. Moving on very quickly here to bigger topics. This data, by the way, is very important, right? I use Netflix here. This is a few years old. They actually declared that they make $1 billion a year incremental revenue because of their ability to help you choose what to watch next. That alone, from an engagement and consumption perspective, actually adds $1 billion to the bottom line. At Disney World, of course, we live in a different world now where a lot of the parks are closed, but they embraced wearables in a big way. $1 billion investment. They became the 4th largest distributor of wearables in the world. Turnstile transaction time, meaning waiting time, down 30%. Labor resource management improved by 20%. So that same team could effectively be 120% more productive, right? Now that brings us to the world of IoT, right? And IoT brings a whole set of questions in it, right? Billions of devices and sensors communicating. This is a world, ladies and gentlemen, this is a world that is completely uncharted in the following sense. We don't have an identity story. We don't have a security story. We don't have, how does a device know who does it report to? What has your webcam been up to recently in your home, right? It very likely was hacked and utilized as part of a denial of service attack somewhere else, right? All of these things need to be resolved, and as we go to machines that become more autonomous, that danger of figuring out kind of true identity and what to do about it. And these are new frontiers. In cybersecurity, a lot of the assumptions, for example, are around kind of securing the perimeter. What happens when the perimeter disappears, like we had with COVID, and everybody had to work from home or from anywhere? What happens when in IoT, there is no perimeter? It's everywhere, right? How do you protect that? And we need a whole new set of thinking around that field as an example. Digital transformation, which was actually driven dramatically by COVID, unfortunately, bad reason to drive a reasonable thing, actually generates a lot more data than organizations are used to. So most of them are kind of overwhelmed and don't know what to do with that data. Typical situation when I talk to a large company or a large organization, Business wants data to be reliable, affordable, timely, accurate, comprehensive, unified, accessible, easy to understand, and easy to embed in business actions. Reality, unreliable, expensive, batch and slow, questionable quality, incomplete, fragmented, what have you, right? And that is why we need that kind of revolution to enable data to be useful, which in turn will enable AI to be real. And without data, there is no kind of workable, pragmatic AI. And that I just wanted to. And I mentioned this, 90% of data in any organization is unstructured. Unfortunately, most databases speak structured only. So we live in a world where you spend all your energy trying to extract structure from unstructured and analyze only the structure. Guess what? There are other modalities, right? Google search engine works. There are many techniques now with deep learning and so forth that work on unstructured data, etc. Yet, if you can't manipulate, track, and keep that data available for algorithms, you can't use it. By the way, you hear a lot about successful machine learning projects. You hear a lot about, to me, the biggest example is Google, right? As MLR, right? Machine learning relevance inside the search loop. Today, nobody knows what it doesn't use, by the way, PageRank, which is what enabled Google in the old days. It uses about 500 variables that are prioritized by a machine learning algorithms that's driven by click-through feedback, but more importantly, there's a huge army of human beings looking at search results. They're called editorial. We have them at Yahoo. We have about 20,000. Every serious search company has them. A lot of relevance feedback is given by humans. That's very expensive, but you don't hear people talking about that. In autonomous driving, the most expensive part by far of that machine learning project is labeling the data that's collected, right? And nobody talks about that, but labeling is the huge expense. It's in the billions for any of the companies that is trying to kind of label data to drive autonomous driving. So to summarize, reduce your problem to a domain where complete knowledge is possible, and that's by narrowing typically. Data is a necessary enabler, and therefore you must have a data story. It's so essential to have a data story, and I was so happy to hear Larry talk about Dan's effort. Of course, we've lived this many times, but we used to focus on the machine learning part when I was at JPL and not think too hard about kind of what's the bigger data story here. And now it's becoming way more important. AI and ML expect data at different granularities and formats, and you need to have systems that are able to feed them that. Most people are challenged with that. You need to model intent and use, and therefore have that intelligence to understand what's going on. And no autonomous AI, no general AI. You have to think about AI with human in the loop is my fundamental belief here, at least to make it through the next winter. So AI is not about replacing the human with the robot. AI is about taking the robot out of the human. I love that quote. I think it comes from MIT Media Lab, if I'm not mistaken. But I think it's correct. It's about focusing on the robotic stuff to be done by robots, the human stuff that today only humans really can do decently or do a decent job doing it. And remember, we don't have better algorithms, we just have more data. So what are we doing to manage and capture all this data is the question we all should be thinking about really hard. And how do we ensure that this data is available as an asset, not as a liability? By the way, the promise of data as a valuable asset has been around for a long time. Data is the new oil, or all that kind of articles you've seen, yet it has failed to deliver. If anything, if I look at the world, and excuse me here, I'm just going to give you my view, there's a huge divide. There is a divide between the AI haves and the AI have-nots. The AI haves are companies like these, right? Netflix, Facebook, Twitter, of course, Google, eBay, Tesla, etc. These are companies that have embraced machine learning and data a long time ago and have been working at it, where they created this huge divide. Typical organization today looks at it and the divide is non-traversable, right? It's like, how do I cross this? These guys are so way ahead. Guess what? They got way ahead by incremental, sustainable, repeatable, and in the beginning, very silly work when they started kind of with an axe and pick trying to kind of dig a ditch. That ditch became the size of the Grand Canyon these days. Now, I say the same is happening with a lot of scientific attempts or attempts to apply this technology in science. The divide is so huge. Where do I start? How do I get the data together? How do I get this going? How do I sustain it? How do I keep my models refreshed? All the things you don't think about because you're not doing it in production mode, whereas these guys have been doing it in production mode for so long and have driven themselves there. By the way, this holds for these buildings can be industry, or as far as I'm concerned, could be universities and scientific research organizations with all the data that's overwhelming them today. Looking to the future, we said no data, no functional AI, yet most enterprises still don't get that message. I think it's a huge message and it's an essential message. What do we need for a proper AI data science ecosystem? Well, you need a strong data and compute infrastructure that's available. The cloud is a good solution, but it's not the solution to everything. So you need to think about edge, cloud, and what's called nowadays fog, which is in between the two. Data as a service is a formula we converged on. Basically, turn data into utility. Don't have your specialized teams spend their time trying to figure out the data problem. Build that data solution and then make it available as a utility where the bar is lowered for using that data for analysis, for achieving tasks, etc. That's when data science, data mining, machine learning can leverage the data properly. An ability to share data safely is a big deal within the organization and outside of it. Probably for scientific data, not as big a concern. For a lot of other sensitive data, a huge concern. And the proper permissions, meaning in my world at least, consumer opt-in, getting permissions that are clear, correct, done right, etc. And of course, the biggest ingredient is you need to have that right talent in data science. You need to be able to attract them, and the harder part is retain them. I could give you a whole talk around our effort to set some standards for data science. Who should call themselves a data scientist? You know, we live in a world where, because of the huge demand and the huge pay packages, everybody's claiming to be a data scientist, and most employers don't know how to evaluate a data scientist. What should they know? What is the standard? So we're doing that in a non-for-profit effort called IADS, Initiative for Analytics and Data Science Standards, iads.org. I encourage you to contribute to it if you're interested, and I'm hoping to do a lot more with it at Northeastern as well. What does this all mean? And this is my conclusion for data analysis in science. Well, I mentioned this 25 years ago. We held the lead. The new digital giants are way ahead now. We're on the wrong side of that divide, folks. The same approach that created the AI haves and have-nots can be adopted by the science communities, but we just need to kind of organize around it and get systematic and get methodical and start leveraging and sharing. It also requires building the right rational infrastructure. And I'm happy to have those discussions, Dan. I'm happy to have those discussions with you as well as you're thinking through the strategy for JPL, if I can help. It requires thinking about platforms and reusability. That's a big deal. It's not about a quick analysis project. It's about a sustainable, how do I support the community long term? How do I build an asset that over time makes it easier for more people to enter, contribute, and give good results to science? So with that, my final thought is, think about these issues, right? Do you have a unified view of your target of study, whatever it is? Meaning multiple sources fusing together. Do you have the context of events and interactions collected? Context is so important around when you sense that data. It's kind of recorded as a side effect, as sometimes metadata if you're lucky. But many times you lose it, but you can regain it by going back and being deliberate about it. Can you provide data-driven actions, alerts, insights with ease, right? If you don't make it easy, it's really hard. Very few people will kind of pay enough attention, and very few people will be able to contribute. Is data access democratized, secure, enabling easy analytics? And can your data enable intelligence in the environments you are targeting, right? Do I have the right data to enable AI? Can AI then help me, and can it help me in the right way? Probably with that, I'm hitting my time, and I would love to have questions if you have any. I don't know, Rich, what the format is. And of course, feel free to get in touch. And I would love to engage with you guys if it makes sense to also, go back to the refreshing world of science data analysis and it was really a fresh of breath air to me personally to just hear someone talking about, you know, new frontiers, new spacecraft, new places. I really miss that about JPL, kind of, you know, thinking outside our planet. And with that, I'd like to conclude.
Usama, thank you so much for your insightful remarks, and you know, from all your experience and achievements, I think you are most definitely someone we want to listen to. I too regret that we're only doing this virtual interaction, but I look forward, you know, sometime soon, hopefully, that we can catch up face to face and explore, you know, more deeply. So as far as the questions go, there is a Q&A available to all the attendees. And so people can place their questions there, and I should be able to see them, and I'll be able to bring them forward. But to get started, I have a couple of questions for Usama.
Sure.
So you mentioned the third AI winter is looming, and now I have a better sense of the new work you'll be doing at the Experiential AI Institute in Northeastern, with the emphasis on human-machine interaction. My question is, how can or how critical is the making progress in the human-machine aspects of AI to be able to navigate through the next AI winter? And it's kind of an adjunct to that question. There's a couple of challenges that we're all aware of. I hesitate to use the terms because they're a little bit overused and maybe even hyped. But the terms of explainability and trustworthiness, which go right to the heart of the human-machine challenges. So if you could comment on that as a way of navigating the next winter.
Excellent question, Rich. So number one, in a way, speaking for AI as a field, we lost our way, right? We got over-obsessed with this regression approach, call it machine learning, right? We were able to shortcut a lot of the problems that, you know, I don't know, 20 years ago, Rich, we were kind of high up on our list. We got to solve it. We got to think about this. We got to do planning. We got to do, and people just took the easy way out. That easy way out is hitting its limits in many ways. Some of them ugly and relate to the second part of your question. Over dependence on a machine learning-based approach to intelligence not only kind of diverts you from trying to solve the real problem, which actually still needs attention. And honestly, that's going to be the next breakthrough that will take us out of the next winter. Is really, you know, coming up with ways to explain, look, here is how this piece of intelligence at least works. And it's different than just regression and machine learning. And by the way, I love machine learning. It's all my life, but I still call it regression without any disrespect because that's all it is, at least in how it's used today. You know, clustering and all that takes us beyond, but that's a whole other topic. The second one, around explainability and let's call it responsible AI or fair AI. This is a huge deal, right? This is a huge deal, and it's a big topic we're tackling also at Northeastern because it is kind of the next frontier. When you make a machine in charge, you're entering very dangerous territory. And I'll give you something that you know, many of you may not think about. Google search engine, which I mentioned. A small adjustment by Google search engine responding to some data pattern could completely wipe out a part of the economy, could completely wipe out, you know, startups and even big companies, right? Because suddenly they used to get kind of traffic and business based on kind of being found in a certain way, and that suddenly changed, right? Do we understand why the change happened? Today I could tell you no one does, not even at Google. No one really knows what that algorithm does to decide what pages make it to the top, right? It's decided by a machine learning algorithm. Many of the decisions that we're seeing around, you know, credit decisions, around healthcare and insurance decisions, around inadvertently end up using, depending on this magical box of AI, to make decisions that can really hurt you, right? One favorite example of mine is, you know, with COVID, all of us are probably using, I don't know if you're like me, but you're probably using the, you know, pulse oximeter, right? And, you know, it's a device that uses the light to kind of guess the level of oxygen concentration in your blood, and, you know, guess what? That device is also used as a monitoring device, etc. And if you start using it, many people don't know that, for example, if you have darker skin, that device doesn't work as well, right? Which gives it very biased results. Even though the blood oxygen might be high enough, it's just that the device has its limitations. And understanding that and making sure that a system that uses AI to kind of use that as an input, understand it, is a big deal. I'm seeing a lot of ugly work happening around kind of analyzing people's faces and guessing like your political orientation or your likelihood to be honest from your facial features. Sounds crazy, sounds Hitlerian, and trust me, it is happening and it is scary. And we need to get to a point where when these decisions happen, we have clarity, you know, the glass box instead of the black box, have an understanding of why they did this. And it's okay, part of the explanation could be, hey, we can't really explain it, but here's correlations that justify it, help us fix it, right? If it's incorrect or if you have a counter. That ability to kind of open up the black box is going to be also extremely important and will avoid us having a lot of trouble. I mean, we all should be worried. These things, AI is getting weaponized. Many of the drones can make and many of the turrets, for example, can make a decision to shoot. And you know, what they shoot at is a big question, and why. So you know, we are entering a very dangerous zone where we really need to take control of it. Thank you for asking that question, Rich.
Okay, I see that we have a number of questions in the Q&A line now, so let me go there next. From Stuart Stevens, how big of a challenge is protecting privacy?
Very big challenge. I think the good news here is we have very good solutions, right? The solutions are a matter of policy, they're not a matter of technology. Technology-wise, we can solve the problem in many ways. The policy, though, should be, it's all about disclosure and opt-in, right? Now, I mentioned that I use Google Maps, and I don't mean this in any negative way. If you're using Google Maps to navigate, you are reporting your position back to Google every 6 seconds or so. Google will know all sorts of stuff about you. But Google was very smart about this, right? They basically said, if you don't opt in for us collecting this data and utilizing it, you can use us in a logged out mode, in which case we won't track you, we won't remember your searches, we won't remember any stuff. But guess what? 70% of the searches you make are for searches you've done before. 80 some percent of the places you navigate to are places you've gone to before. That convenience of just clicking on a prior location or allowing the system to guess where you're trying to go is so powerful that I actually say, okay, fine, you know what? Darn it, I'll log in and you can track me, right? Despite the fact that I'm so concerned, but at least I feel reasonable about it because it's been disclosed to me. Now, unfortunately, for the majority of the people, they don't understand that and they get surprised later. So it's important that we have the transparency side and what I call the meaningful opt-in. My favorite example on privacy is that works really healthy. In the days when we used to travel, the airline loyalty programs, right? I would go out of my way to make sure that airline is tracking me, right? I'll go to the desk, hey, do you have my number in there? And in fact, if I'm going with my kids, hey, do you have my kids' numbers in there? Why? Because I actually value the return I get, the perk I get, the benefits I get. And it's a meaningful economic exchange between me with full disclosure and that company. That is kind of a healthy way to do it that allows you to decide over time, you know, what do you want to share and what you don't want to share. Unfortunately, not many of these are done by opt-in and not many of these have meaningful exchange of economic value. So it's very questionable how that data is collected, right? You know, most of the traders on Robinhood don't know that the way Robinhood makes money is by looking at their trades and selling that data to the hedge funds and the big trading firms to report on activity, as an example, right? So as they say, if it's free, you are the product. So you need to be very careful.
All right. I see one of our NASA program managers is putting a talk, so we'll go there next. This is Sengar Lee, who manages the NASA High Performance Computing Services. This question is how we might be able to bridge the digital divide. Government scientific enterprise does not monetize our data. Our investments do not allow hyperscaling. So what is the strategy for us to cross this divide?
I think one of, look, I don't have all answers, right, to the problem. It's always challenging to cross that divide. However, two methods that I think are reliable is, as you think of funding projects for data analysis, right, or getting those projects done, a component of those should systematically be around kind of platform leverage and repeatability. If we start thinking that way, A, our attempts to analyze, our attempts to exploit the data become cheaper and more effective over time. And B, you get to subsidize the cost of the build up that infrastructure on that. The second part is think of value, right? How do you deliver the value and how do you package it enough to, whether it's capturing mind share or whether it's actually literally figuring out how do I make this information more useful in an economic sense to someone. It is not far beyond many companies. By the way, in drug discovery, this happens all the time. Companies will actually pay for data to be collected. In retail, companies will pay for the data to be collected. In scientific studies, I claim, especially ones having to do with earth sciences, there is a lot of information that can be monetized in reasonable means, and be where the funds can be used to kind of help us build more sophisticated systems to bridge the divide. One of my, just to give you an example, one of my favorite kind of examples is, you know, small startup, I forget its name now, that did very well. But what they did was they utilized satellite photos and kind of other data available from flyovers to look over things. I mean, of course, this is used in agriculture, crops, all that stuff. But look at this one. They fly over China. They look at the oil tanks that are basically these big round things. These oil tanks have a movable top, right? Because as the tank fills up, the top goes up because you don't want gas with a lot of oil vapor in it. And as the level goes down, they go down. Guess what? Looking at the sun angle and the shadows, they could estimate the level of oil in all of those reservoirs, right? Which immediately tells you, oh, is China going to have to order more oil? Are they going through a shortage, etc.? They take that signal and sell it to a whole bunch of hedge funds, trading. Now, that satellite, I bet, was put up there not for commercial reasons, but for defense or scientific data gathering, more likely scientific. But these guys figured out how to be clever about it and say, look, we have access to that data. Let's put it to use, right? So to me, this is how we need to start thinking around it. There are many economic ways beyond grants and big kind of projects to fund our work, and we need to start thinking about that.
All right, thanks, Usama. I'm going to try to go reasonably in order here. Next is from Sungbum Kim. Autonomous driving may replace human drivers. How could the Media Lab model, AI is about taking the robot out of the human, apply in this context? So the question here now, I agree with you, it's going to disrupt what comes out of it. And look, I'll tell you, Uber and others, I mean, the reason they invested in autonomous driving is that, you know, a driver driving a car costs roughly, I think, $2 something a mile. A robot driving that car brings it down to like 50 cents to 75 cents, right? So they have reasons to kind of do it because they want to offer that same service for free. I'll tell you two things. Number one, I don't think we need to worry about driverless cars in that space where kind of humans operate today in a key way for fast-moving vehicles, because the technology won't be there in the short term. In the long term, much like, you know, nobody predicted that as we built systems for, you know, with spreadsheets and accounting systems, that the job of an accountant would completely change from being, you know, you're pretty good at kind of opening this big ledger, you have to have good, nice handwriting, and good addition skills in your head were extremely important, right? Look at that work, right? So manual, so laborious. When you replaced it with accounting packages, it's not like we eliminated. We have more accountants today than we ever had before. And what they do is of so much more value to the companies, and I think that's the reason why we have way more accountants.
so much more value to the company than kind of flipping pages and writing stuff and erasing it, right? So that and adding stuff in your head. So that, you know, I don't know the dynamics of what that will mean, but the reason I'm bearish on technology, I'll use a personal example. About 3 years ago, back when we used to travel, I land in Chicago airport. I'm going to visit one of our clients, State Farm, which is down in south of Chicago, in Bloomington, Illinois. And as I'm driving out, you know, I arrive, I pick up the car, I'm in a hurry. They say, well, we don't have the car you reserved, but lucky you, you've been upgraded. Here's a Mercedes Class A. Great, you know, I love Mercedes, by the way, and Rich knows it saved my life and my past. But I get in the car, I'm driving, and every time I try to pass a vehicle, right, the car slows down, almost slams on the brake. I'm in the left lane on a highway, right, and it's like slowing down. Every time it happens, it's slowing down. So it took me about 2-3 minutes to realize, oh my God, these sensors must be misaligned. They're looking to the right instead of looking straight ahead to prevent a collision, right? So I need to disable the system, and I had to figure out a way to finagle my way to the emergency lane and spent, you know, 5-10 minutes trying to figure out how to disable it. But here is the theme. If you woke up in the morning and you went to the bathroom and looked in the mirror, and instead of seeing your face, your eyes were looking sideways, what happens to you, right? You probably will feel extremely ill, very dizzy, and that's the way your brain is using to bring you down, right? It's basically saying, don't even leave the room, don't get out of the door, right? That ability, and by the way, I use Mercedes, I love the company, but I use that example because they are a high quality company. You know, this is, they're putting all their engineering and testing and kind of world class, but try to think up all the scenarios that might interfere with that sensor, be it alignment, be it somebody kicked it, being a bird pooped on it, being, you know, whatever it is that could kind of interfere and cause problems. That space of unanticipated events is extremely difficult to cover today with a machine learning approach that we are taking towards autonomous driving, which is why I believe slow-moving vehicles, yes, we will have that. We will have garbage trucks driven by robots, but they will need, you know, the human drivers to kind of be available to intervene and kind of parachute in remotely and say, you know, the truck needs to be able to say, hey, I see something weird, I'm stopping. And by the way, it can stop, right? It's not mission critical for it to move at high speed. It stops and waits. And when the human comes in, they can look at it and say, oh, that's just a balloon, or that's a cat, or that's a baby, or that's a tree branch. So that kind of capability is still not there. That's not how we're thinking about driving. So we have a long way to go to get to fast-moving vehicles and kind of cars being autonomous. Now, I know many people critique me all the time. I used to say this 4 or 5 years ago, and people would say, Usama, you're a Luddite, right? You know, we're going to be having cars driving in 5 years. We will have amazing demos. We will have amazing capabilities, but we're not there in maturity yet.
Well, thanks, Usama, for unpacking how subtle the technical challenges are in autonomous driving. We're going to pause here. There are additional questions that we have recorded, and we can convey those to you, Usama, for you to follow up on. Right now, I'd like us all to thank our excellent keynote speaker, Dr. Usama Fayyad.
Thank you for having me, and I look forward to a personal visit with the team at JPL and Caltech. Please.
Usama, thank you so much. We had so many questions. So we're going to actually, I think we're looking for ways to set up a communication channel. There was a proposal, a Slack channel for all the questions that people have to start on the workshop. So we're looking real time to work some of those issues. So stay tuned.
And by the way, I'm more than happy, I don't know if I'm still on, but I'm more than happy to, if you gather the questions and send them to me, I'll work with the team here to kind of push them out either on LinkedIn or somewhere reasonable so we can answer each one of them, because I'd love to blog about this and add in the questions from the audience and the answers that I didn't get around to answering.
Yeah, we'll do exactly that, Usama. There's some good ones in there, including about ethics.
Yep. Thank you.